Hi, I'm Brian Sather, and for the next few minutes, we're going to take a look at using the shape generator feature inside Autodesk Inventor to lightweight a design. Now, I've started by pulling up a relatively simple model of a steel bracket, and what we want to do is remove as much material as possible while still maintaining enough stiffness to do what it needs to do. I'm going to start by going into the shape generator environment. You'll notice the icons right there in the 3D modeling part of the toolbar, because this really is not intended to be a simulation or a validation tool. It's there to help you as you're designing the part. Now the first step is to assign a material, and if you've already done that, then it will be carried over, or you have the option to override it. Here we're going to use steel, but note that the material used does not play a major role in the optimization. Whether it's made of steel or styrofoam, it's going to attempt to reduce the mass of the part by a percentage of its original weight regardless of which material it was. Next up, we need to assign the constraints and loads. The constraints define how it will be supported, just like in the simulation environment. In this case, we're going to apply two fixed constraints to the faces where it's bolted down to the larger assembly. You also have the option to apply pin or frictionless constraints, just like you do in the simulation environment. Then we'll add a force to the surface up here. For this part, we're going to use a 100 Newton force on a face of this upper slot. And again, there are additional options for applying pressures, bearing loads, or moments, if that's the type of force you'll be using. Now the last few steps have to do with the goals and constraints of the optimization itself. Now in most cases, there are areas of the geometry that need to be preserved. For this part, we need to make sure that areas where it's connected remain intact. So I'm going to add a bounding box and use the arrows to resize it to capture the areas that we don't want touched. This can also be done using a bounding cylinder, which works well if you want to preserve a certain amount of material around a hole. There's also an option to define symmetry. This will make sure that the generated geometry is the same on both sides of one or more selected planes. You can use a local coordinate system that you've defined, the center of mass, or the center of a bounding box around the geometry to pick the symmetry planes. Now in this case, I've already set up an LCS right in the middle of the part so that the left and right side will be identical. Now the final step in setup is to establish the criteria for the optimization itself. The mass target determines how much material the analysis will remove from the original geometry. This can be done based on a percentage or by specifying a target mass. So our target for this part is 350 grams, which will remove about 60% of the mass of the original geometry. There's also an option here to specify the minimum member size, and this is there to make sure the generated shape can be manufactured how you want it. Now for this example, I'm going to set it at 8 millimeters so that we can easily mill this thing out. And finally, the mesh resolution is there to specify how big or small the elements will be in the mesh of the generated shape. Now generally, this should be about 3 times smaller than the thickness of the part and the minimum member size. The value you see is actually a percentage of the longest dimension of the bounding box. And since this part is 194 millimeters wide, that is our longest dimension. If you don't want to do the math, Inventor will let you know if the value is too high, and it will provide a suggestion for where it should be set to get the right resolution. For this one, I'm going to set it at 1.2, which comes out to an element size of about 2.3 millimeters. Now we're all set up to go ahead and run the optimization. I'm going to skip forward just a touch because it does take a minute to run. Now that it's all done, you have a mesh version of the generated shape. If you want to do it all over again with different settings, you can copy the study and adjust it as needed, but once you're happy with the result, you can promote that mesh shape back into the modeling environment. Now it's just a matter of modifying the existing design to match the optimized shape. So we're going to use that as a template, and I'll create a sketch. Now I'm going to start by projecting a few of the points off the mesh that we'll use as guides for the sketch. Then we can finish out the sketch with the rest of the outlines to carve out the regions of the part to remove. And when we're done, it's just a simple extrude operation to finish up the part, and we have our final shape. Now from here, you can go a step further to validate the design, and this is an important part of it. You want to go through and look at performing a modal or a stress analysis to make sure that that updated design is going to perform at the level necessary for its function. And so there you have it, using Shape Generator inside Autodesk Inventor to lightweight a design. My name is Brian Sather. Thanks for watching.